All right, hello and welcome to Solving for Acceleration in a situation where you have multiple forces acting on an object. All right, so let's say we have an object in space. It's going to be a box. All right, and let's say that there's one force pulling to the right. We'll call this force 1. And then we have another force pulling to the left. We'll call this force 2. All right, what we want to do is we want to find the acceleration. We want to know, will this object accelerate? The first thing we need to know is we need to know the mass. Let's say the mass of this box is given, or we measure it to be 15 kilograms. Let's say we measure F1 to be 35 newtons. Let's say we measure F2 to be 22 newtons. All right, so acceleration. That's what we're looking for. The first thing we should realize, we should think of, is what equations do we know that can give us acceleration? Well, we have the 4 equations of accelerated motion, but we don't have anything about its motion, its displacement, its velocities, its time, or anything. But what we do know is we do know something about its forces. So we know the equation that relates force to acceleration is equal to the net force divided by the mass. All right, that's the equation that we're looking for. So the first thing we need to do is we need to find the net force. So we come over here and we say the net force is equal to the sum of all the forces. All right, so let's sum up all the forces. We have F1 plus F2. That's going to equal our net force. So we just simply plug in what we know. F1 is equal to 35 newtons. So we have 35 newtons plus, now F2, it doesn't say it's negative, but since in the picture we can see that's to the left, we can say it's plus negative 22 newtons. So 35 plus negative 22 is equal to 13 newtons to the right, positive. So we now know our net force is 13 newtons to the right. That means this object is really only experiencing a net force of 13 newtons. That's it. That's all it really feels, because all the forces cancel out and only 13 newtons are left over. So now coming over here to solve for the acceleration, we do 13 newtons divided by a mass of 15 kilograms. And a newton per kilogram gives you acceleration in meters per second squared. So 13 divided by 15 is equal to 0.86, repeating, meters per second squared. And that is your final answer.